morning, class.
Good morning, Miss.
Okay, so over the past few lessons we've been learning about Pythagoras' theorem. Now, can anyone remember and tell me about Pythagoras' theorem? Yes?
A squared plus b squared equals c squared.
Correct. A squared plus b squared equals c squared. Now, where did this theorem come from? Yes?
Greece.
Greece, yes. And who designed this theorem?
Pythagoras of Samos.
Yes, Pythagoras of Samos, the Greek mathematician. Now, if I am to draw a triangle, a right-angled triangle, remember, who can label for me sides A, B, and C? Yep. Yeah, does everyone agree with this?
Yes.
Yeah. Now, who can tell me out of A, B, and C, which one is the hypotenuse? Yeah?
C.
C, exactly. Now, what is it always opposite of? Yeah?
The right angle.
Yeah, the right angle. Now, how many degrees is this?
90.
90 degrees. Now, for the first example, we're going to have C as the unknown. C, and we're going to have sides of C. Here we are. Who would like to solve this one for me? Yeah? Okay, stop there. Does everyone agree with what she's done?
Yes.
Identified which sides are A and B and put them back into the theorem. Yeah, continue. Close, but because we've already found that when we bring this one over the square root of the number, we don't have to put the square on the C. Because this is equivalent to square rooting the other side of the number. Yeah? Okay, who agrees with this number? That C should equal 8.6 centimetres?
Yes.
Yeah? Okay, so for the next one, we're going to have A as the unknown. Now, who can tell me how do we rearrange this theorem so that A becomes the subject matter? Yeah?
Isn't it? No. A c squared equals b squared taken a squared.
No. Close?
A squared equals c squared minus b squared.
Yeah, correct. A squared equals C squared minus B squared. Now for this example, we're going to have C as 10 and B will be 6. Now who would like to use this theorem to solve this triangle? Yes? Okay, does everyone agree with this one?
Yes.
So we've got 10 minus 6, put them down, find out their roots, square rooted them together, and it will equal 8. Yes?
When you do 10 squared minus 6 squared, don't you write equals a squared?
Yes, good point there. It should be included that it equals a squared, just to make sure that you can check that you're on track with each process. Now in doing these, how was it that you really understood the concepts? What helped you get through the process? Yeah?
The textbook.
Yeah, the textbook. Does anyone else have any other ideas? Just the textbook helped?
Product might also help the class.
Yeah, the class demonstrations, good, good. Okay, your own right angle triangles. So they can be any size, as big as small as you like, but for the first one, have C as the unknown side. That's what you're going to be finding. Okay, so I'm going to be doing a demonstration as well when you do the triangles, just so you can refer to it if you need to. So we're doing A squared plus B squared equals C squared. Okay, does anyone need any help with this? How are we going so far?
Good. Can I do 8 and 5?
8 and 5, yes. These can be of any size. Yeah. Yeah, very good. Put it back into the formula.
Am I allowed to use a calculator, please?
Yeah, you can use a calculator. Just try, if you can, work out the process on your own, just using your own mind. Yeah. Does anyone need any help? Yeah? What are you stuck on?
The beginning bit.
Yeah, so remember the theorem is A squared plus B squared equals C squared. Yeah, very good. Yeah,
So it's the A right there.
the A.
It's triangle.
Yeah. Yeah, so for your second triangle, you're going to be finding A. A is going to be the unknown. So if we're going to have A as the unknown, this means that the theorem is going to change. Now who can tell me how we rearrange this theorem so that A squared becomes the subject of the formula? Yeah?
A squared equals C squared minus B squared.
Correct. A squared equals C squared minus B squared. So when you do your next triangle, where you have to find A as the unknown, we're going to be using this theorem. It's the same, just rearrange that A will be what you're trying to find. And remember, when you're making up your triangles, C has to be bigger than B. Can anyone tell me why? Yeah?
It will be unbalanced if you don't do that.
Yeah, it'll be unbalanced because
And
if
it won't
we
be
have,
negative.
yeah, it'll be a negative. Because if we have a 5 here and say 6 here, and we minus them in the formula, it becomes a negative number. Yeah?
How do you do the second bit with the A one? How to find what A equals?
This bit, is
Yeah.
this the one you're referring to?
Yeah.
Yeah, so you've got A squared equals C squared, we've run B over, so it becomes minus B squared. So that'll help us find A squared on the new triangle. Yeah? Do you need help? Yeah?
I finished this one. Is there a B squared that we can do?
Yes, you can also find B. Now, how would you rearrange that theorem so that B will be the new subject matter?
Would it be B squared equals C squared take away A squared?
Yeah, correct. So if we want now B to be the subject of the theorem, we have to bring A over to the other side. It makes it a negative, yeah? So B squared equals C squared minus A squared. So if you want to do another triangle, if you've already finished these two, you can make B the unknown, but just remember that this side must be longer than this side. Because if we minus them, they won't balance, and the number will be what?
It won't be negative.
No, will be a negative, yes. Because if this number's smaller, and you put it into the theorem, and you take it away, it'll be a negative number. Yeah? Does anyone need any help? How are we doing? Yeah, you put that into the theorem. Good job, good job.
I'm just going to get this here.
Yeah, so we've got 100 minus 49, so it's 100 take away 49.
51.
51, yeah. And we put the square root of 51 into the
Oh.
calculator.